All right. Welcome everyone again. Our next talk is underlying plugin architecture for Python packages by Ashish Shukla. Over to you, sir.
Thanks. So my name is Ashish. I do software at EPAM Systems, more specifically Python. I've been doing Python for about 10 years now. Um the thing that I like most about Python is how there is a package for almost everything. But on the contrary, most of those packages die soon. They become obsolete. One reason that I have felt is when someone creates a package, it's mostly keeping the requirements of that instant in their mind, and that's about it. And when I say packages, I don't mean the Hello World packages that you and I create just for fun. I mean the packages that dedicated teams create. They also die. They also become obsolete. So extensibility, especially in terms of Python packages, plays a plays a critical role. Now, one way to address this challenge is using something called plugin architecture. It exists in every language, but it's PyCon, so I'll be talking about how do you implement plugin architecture properly for Python packages today. All right. So, what will I be talking about? I'll try to talk less and show more. Uh, the talk is largely divided in two parts: how plugins work, some theory around this, probably first 10 minutes, and then how you can actually make it work for your own package. We'll try to build a CLI, we'll try to make plugins for this, and so on. There will be a little bit of hands-on involved. Fingers crossed I don't break anything. All right. So what and why of plugins? So what is pretty straightforward, like, right? What are plugins? It's in the name itself. Plugins, you plug something into existing system. It increases the functionality of your existing system, and that's what a plugin is. Now, why plugins? I already touched on one aspect of it, that is extensibility, right? Uh, the other things that you get out of it are you can keep your core package slim. Uh, you you don't have to bloat your core code base. You can let the users decide what do they actually want. I know there is extras also available when you create a dependency declaration in PyProject Romel and so on. But what I mean is a more granular access you can give to the users, and they can decide what they actually want and only install those dependencies. uh, Decoupling the core logic and implementations. So there are almost always two sides of things, two types of code that you write. There is one core logic that you write, which consists of some loaders, some interfaces, and so on. And then the other one is for the implementations of those interfaces and so on. Uh, Plugin architecture allows you to have a clear separation between these two things, so clear that you probably don't even need to share the repository. Get contributions. uh, Now what I mean by contributions here is you can actually create an ecosystem. We'll talk about a few examples of this plugin architecture in Python ecosystem, and then you will understand what kind of ecosystem am I talking about. So how many people have worked with SQLAlchemy, please? Awesome. How many with Airflow? All right. So most of you have worked with SQLAlchemy. Any guesses when it was created? 2006. Too old, right? But it is still exists, and it's still very very relevant. Um I got to know about something called dialects in SQLAlchemy very late. Uh, when I wanted to work with SQLAlchemy ClickHouse. I wanted to utilize querying of ClickHouse, but with a consistent interface of ORM. Uh, that's when I got to know about SQLAlchemy ClickHouse. When I also explored a little bit more, I got to know that there are plugins available for G Sheet and Druid and so on as well. I mean, I didn't even consider G Sheet a database, but there's that. So there are a set of default dialects supported. There are five supported. I have crammed them. I can I can say their names as well. MySQL, MS SQL, Oracle, and SQLite, and there is PostgreSQL as well. So 5 of those are already available. I mean dialects, not the drivers. You still have to install the drivers. So although there are certain dialects supported, but SQLAlchemy can't possibly have dialects for everything, right? Certainly not for G Sheet or something like that. So this dialect allowed SQLAlchemy to stay relevant. Similarly, for Airflow providers, uh, Airflow providers, Airflow actually has concepts of operators, hooks, connections, and so on. For those of you who have worked with it, might be understanding. For those of you who have not, just ignore, consider it some component of Airflow. Uh, and if you want to extend the set of those components, you can install additional providers like Google provider, AWS provider. Probably you want to send notification through Slack, you can just pip install Airflow provider Slack. That's it. So now the question is, we have two packages installed. There is one core package, there is one plugin package. How do you make them talk to each other? Didn't make sense to me at all. So I did what people used to do before ChatGPT. I digged into the code of SQLAlchemy and came across something called plugin loader. Now, most of the plugin loader is pretty straightforward. It's just more or less a registry pattern. But one thing that might not be familiar to some of you is this import lib metadata. How many of you have worked with import lib? How many of you have worked with import lib metadata? Yay, no one. Okay. Okay. So in the import lib metadata, actually import lib serves three purposes. The first one is it provides a default implementation for import. Then it provides you tools so that you can declare your own importers. And the third one is for inspection of the package metadata. So what package metadata means is you can check what all distributions are installed in your current environment. You can check their entry points and so on. So what are these entry points? It seems like if we just know what are entry points, it is our entry point to understanding what plugin architecture should be implemented with in Python, right? So I searched a little bit more, and this is the definition that I saw in Python packaging user guide. It says entry points are a mechanism for an installed distribution to advertise components. And this is actually what you want to do. You have a core package and then you have a plugin, and you want the plugin to advertise what it can do for the core packages, right? And then the core package can probably utilize the plugin packages to enhance its functionality. Now, how do you declare it? For those of you who think you have not declared any entry point, think again, because I'm pretty sure you have. You have definitely built a CLI, and in the CLI, you must have declared this entry point with console scripts, with your script name going here and the path to callable here. So what that console scripts thing is called a group name for entry points. Group name is just a unique identifier to group the type of entry points. So this is for those who are still using setup.py for some reason. Please use py project Tom. This is the way that you actually declare it. Okay, pretty much the same thing. Now, if somebody starts to do this, you guys definitely will come across this error where you will probably use a hyphen or something in the group name. Go through this Python package entry points guide, and all that you can use is dot, underscore, and alphanumeric words. That's it. Okay, so now the part that I'm more comfortable with, how you can make it work for your own package. So I'll do a little bit of demo, and I hope nothing breaks. Okay, so I have some stuff set up here. What we will be doing is I'll create a hello world CLI. Uh, no prizes for guessing what it will do. It will just print hello world. That's it. Uh, it will have an English language implementation by default, and it will have a plugin loader. We will also implement Kannada language plugin that allows me to print in Kannada too. Now that will be a plugin. The core functionality just has English and a plugin loader. That's all. Okay, so I already have this virtual env set up here, this hello world package and this hello world Kannada package. Both of these are installed in editable mode in this virtual env. This is the setup that I already have for you guys. We'll start to populate it now, and I'll talk as I type. Okay, so I guess the virtual environment is already activated. Right now, HW type prints nothing. If I print hello world, it should print hello world here because it is installed in editable mode. I probably want to have a language parameter here, right? And that should be an option. This option comes from Typer. If you guys haven't used Typer yet and are still using Click, I encourage you to look into Typer. It's by the same person who has created Fast API, and it's just as good. Okay, so in option, it probably should take a click type, and in click type, we want to give a choice of the languages. So let's import choice from here, and the choice will take an array. We'll give the options here: English, Kannada. I'm hard coding it for now. Okay, the default, there should be a default value as well. So let me give it as English here. Now let's do a HW help and see. Okay, so it shows language, English, Kannada is available. If I'll pass HW double dash language equals English, it will take that parameter, print it alongside here. If I do something else, it will take that. So hello world in English and hello world in Kannada. All right. Okay, so now let's go about implementing the plugin base structure. Now, in order for you to be able to define what a plugin should look like, you need something to communicate with others, uh, what their code should look like, right? What do we do? What do we do when we want to tell others what their code should look like? We declare interfaces. We don't have interfaces in Python. We will declare a abstract class. So I'll create abstract class. I'll call that base language. And I'll have abstract method. This would be called say hello. Doesn't take anything, doesn't return anything, just prints hello. That's it. So let's add a basic implementation here. English language, base language, we have say hello, supposed to print hello world. Now let's implement the plugin loader. I'll call this language loader here. Now, what should it look like? It probably should have a implementations cache somewhere. You would want to get one language by the name from it, right? So it will return the base language, take the name of the language. You probably want to do self return impulse name. You probably want to also register a language here. So name, and then you can give the lang, and this would be of type base language. You do something like impulse name equals lang, and probably I should also have something called keys, which should tell me what all languages are registered, right? So list self impulse, and now the last part, load other languages, right? So what do we do here? We want to go through all of the entry points now that are relevant to my package. How do I do that? I do that using import lib. From import lib, import metadata. And you do something like HW endpoints, and you can do metadata dot entry points, call this function, call select, pass a group. Group is supposed to be hello underscore world. You can keep it ABC or whatever. It's just that whoever is building the plugin for your package must know what the group name is. Otherwise, you won't be able to identify, right? So these are all the endpoints that I have. I'll do something like for EP in HW EP self dot register, pass the endpoint's name. What is this endpoint's name? This endpoint's name is uh, this. The group name is this. And when I will do ep.load, what will it load? It will load whatever callable you have given here. All right. So this much stuff is done. Let's use this registry. Registry equals language loader. Let's add our default language here, which is English. And for lang, I can pass English language. I will do registry.load later on so that you guys can actually see that it's actually discovering the plugins and I'm not cheating. So I do have a little bit of cheating here though, right? Choice. I have hard coded it as English and Kannada. Shouldn't be like this, right? Now we can just use our registry keys. You can do from hello world dot base import registry. You do registry dot keys here. And now you will get the language name here. Now you can simply call registry.get, pass the language. It should return you the relevant class. Let's assign it to CLS, instantiate it, call say hello. Probably a better way to go about it could have been to declare that as an abstract class method instead of abstract method. Doesn't really make sense to instantiate it just for printing hello world, but it's like whatever. Okay. Okay. Now if I do HW double dash help, first thing first, Kannada is gone, but English is still here. So now I do HW and it prints hello world. To verify that it's actually printing from the plugin that we have created, the default one, let's add one more asterisk here. Exclamation mark here. Okay, it is definitely coming from here. Now let's extend our package. This package is installed in the same virtual environment. I go here. Or actually, let's first break it and then fix it. Let's go to base and do registry.load. Now, as this package PyProject Toml already declares that I have an entry point hello world, and this is supposed to be where the entry point class resides, but the class doesn't exist here, it should break. And it breaks. Now let's fix it. So what do we need to do to fix it? We just declare the class, right? So I go here. Now, in an ideal world, what the person will do is when you will give the core package, the person will install your core package and they will use the interfaces that were declared by you. In our not so ideal world, we will still do that, but the person has not installed the core package here because both are sharing the same virtual environment. So we still get the base language here. We implement it, def, say hello, do a print, do a little bit of cheating now, copy it from here, paste it, and that should do the job. Okay, so HW, now at least it doesn't raise any error. Now if I look into the help, now it has Kannada. Now let me go to base once again, comment this out, Kannada is gone, load again, Kannada is here. Similarly, let's say some aliens visited Earth and they wanted to use my great Hello World package. They can just declare their own custom language package, and we could all speak Hello World in their language as well, right? But you get the idea what the actual usage of this is. Uh, so now let me do HW language equals Kannada, and it works. All right. So what's a more practical use of it? Maybe you want to create a notifier package, right? You don't know what all ways you can send the notifications with, right? Slack, Teams, XYZ, I don't know, nor do you. So what you do is you create a notifier core, and you declare the notifier uh, uh, notifier interface, and let others know that this is how they should be declaring their plugins, and let others know that we can use the plugins that they will declare. They can keep their own dependencies in their own packages. We just need to have a loading mechanism, and we just need to have a core implementation with us. That's it. Okay, let's try to summarize whatever we have talked about. So I basically summarize it in three parts, the whole process. Let others know how they can create code for you. Plugin interface, essentially. It could be dialect of SQLAlchemy. It could be provider interface of Airflow. It could be the base language that I created, or base notifier for the notification package, whatever. Give them an identifier so that they can tell their code is for your package. It is the group name, the entry point group name. Uh, then write some code that can load their code, like the plugin loader. Now, this mechanism of loading the plugins can be much more sophisticated than what I showed you, but the underlying principle remains the same. Uh, to get a little more idea about how sophisticated it can be, look into how Airflow has implemented it. I have added the reference to Airflow's relevant docs at the end of uh, this PPT. You guys can check that out. Now, the conclusion for this third point is, I don't know if it will happen or not, definitely, but the first two are definitely summarizing whatever we have talked about in this. Plugins stand for extensibility, and entry points are the way to implement plugin architecture in Python for your packages. So these are the references. I have cherry picked some uh, code bytes from SQLAlchemy and from Airflow as well. Go through these, you'll probably enjoy. Uh, I think that's all that I wanted to talk about. Find the slides and the code that I have written here. Uh, you can connect with me on LinkedIn as well. So that's all from my end. If there are any questions, please feel free to ask. I wanted to leave enough time for questions because I suppose there should be some. Please ask. No questions? Yes. That depends on the dependencies that you have declared, right? Let's say I'm using my package is using. I mean, it's not specific to plugin architecture. Essentially, it's just the way that you define the dependencies, right? So please explain to me, like, why do you think that may be the case here? Mm-hmm. 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 So what does the dependency tree look like? Is there anything going back? We're just using their code. We are not installing their package as a dependency to our core package. It's like the core package is being used by this, so it's still a DAG only, the whole dependency tree. There is no circular dependency happening here. You're just loading their code. That's about it. Yes. So I just talked about the registry pattern. That's one of the patterns that you can use for storing the plugins. The rest of it is pretty open ended. I would say adapter is one of the patterns that you can think of uh, to basically adapt to different kinds of protocols. What I mean by protocol is you have a certain contract that I will send the notifications when you call this method, and then the person can probably call a webhook. The person can probably do a whole email payload creation and send an email or whatever. So adapter is probably one pattern that I can think of, but it's pretty open ended. Whatever you want to do, uh, all that my suggestion is that you use the entry points load and get others code using that way. That's it. Uh, I think the best resource for understanding how to code is to read others code. Uh, read these, and you will understand how stuff actually works. I'll stress on this once again. Go through Airflow's implementation. It's beautiful. Any more questions? Yes. Okay. So it depends how you actually view a community based project or an internal project. I actually worked on an internal project for another organization, not my current employer, where I used this plugin architecture because there were a lot of teams working on these implementations, and those implementations were very big themselves. uh, this actually came in handy for even the internal projects. But I would kind of say that it's definitely more geared towards the community driven projects. So, yeah, I partially agree with you. Yes. Okay, so the square brackets thing is what I was talking about initially. That's actually declared in the extras of the dependency declaration of your own package. So let's say I talk about MLflow. MLflow is one package where there are some optional extras that you can download. Here, the plugin is a separate package altogether. So you first do pip install SQLAlchemy, and then you do a pip install SQLAlchemy ClickHouse. So those two are kind of different things that we are talking about here. Any other questions? Yes. Great question. So you saw that we had something like a registry, and we implemented English language ourselves, right? Okay, so think of it like this. You as I said, even in a general code base, you will always have the core logic and then the implementation logic. First thing that you should do for legacy packages is you should identify what's the core logic and what are the implementations. Create the implementations separately in your own repository. Separate out the core logic. Create a registry like I created. Create a loader for your own packages, and then you can think of creating the interface or exposing the interface to third party where others can create it for your core package as well. Does that kind of answer your question? Awesome. Any more questions? Yes. I guess that's up to you. How will that propagate the interface? You decide the if your code initially is very tightly coupled, I guess you're gonna have a hard time and you'll just give up, and you'll probably create another package altogether. Okay. Otherwise, I would say it's highly subjective, and it will vary very drastically. But one thing that I would recommend is whenever you're creating a architecture like this, Be very sure that your interface segregation is proper. The eye of solid, right? So make sure that your interface segregation is very proper. Otherwise, what you will have is a bloated interface with a lot of raised not implemented errors. Okay. More questions? Yes, please take it offline. Come discuss. Thanks. Thanks, everyone.